How many folks
Yeah,
do we have on?
I was just going to look. I can't tell, of course. Let's see here. Oh, here we see. I see 53. So we had, what was it, 61 signups, and people could still be joining. It's, really close to 12. So thank you so much. Yeah, usually we get about, 25, 30. So this is a good crowd. So thanks for marketing. And go ahead and take it on.
Yep.
Thank you so much.
I'll just give it 5 minutes. I was teaching a class in Singapore, and I thought, am I at the wrong time? Because nobody's in the classroom. And one of the organizers said, yeah, Singaporeans are all 5 minutes late to everything.
Okay.
So I'll just be 5 minutes. I'll give it 5.
Okay, that's fine. So maybe you just want to introduce yourself and your background and give everybody a chance.
Sure. I've been using Pro Engineer, then Creo since 1990, and I think I learn fast, so I tend to spend a lot of time learning new things, which in the end makes me very happy. I I grew up racing motocross and then later sport bikes, and I found that it was exciting for me to learn a new track and see how fast I could get before lunch on the first day. And it dawned on me that that's exactly how I roll with how much fun a typical engineer has with learning Creo. If it's a painful learning experience, you dread it. If you can get fast and gain confidence quickly, it can be a whole slew of fun. Um, which is kind of leads me into training. If our managers think we're smart, and we are, right, we can learn fast. But if they give us the proper tools to learn faster and then ultimately work more efficiently, I call it 1% smarter. If we can be 1% smarter at 300 things, can I be 30% more efficient? If you give me 2% efficiency, I'd be lapping second place on a sport bike race. So I think in the end, my hobby is learning. Whether it's yoga, sport bike racing, riding a skateboard. I've got a CNC in there that doesn't have enough hours on it yet, so I've got a lot to learn still. Which is kind of everybody that works at Design Engine has the same sort of, I think, learning passion. I got one more minute. This past couple years, I pushed very hard to create a manufacturing oriented series of classes. So all of our classes are very geared at manufacturing. So when I say that, I think about a hat that we wear. If I design a part and I don't care how it's going to be manufactured, that's typically how the R&D team works. Then let's put on a different hat and think about, all right, now I've got to add draft to this part, but they started with an import. I have to completely remodel this thing. So it's a very different perspective hitting it with those hats. The R&D, manufacturing, industrial design doesn't care about what software they use. They could use SolidWorks or Rhino for all they care. But which leads into all of our classes. So I'm going to log into the student login here. I like to call it participant login. We're all students of learning. And if you see my training material here, this is the very first page you see. I've been working on the forging classes for a lot of time. I probably built 100 hours putting that together this year alone. The plastics class, I probably put in 100 hours a year, but last year I spent probably 350 hours putting that training material together. So I'm really excited about those week-long plastics classes or die casting classes or forging class. So I'm going to scroll down, and I'm getting past the SolidWorks material. I find it funny that, when I'm teaching a class to a bunch of SolidWorks people, or vice versa, SolidWorks to a bunch of Creo people, sometimes they don't know who I am. I've been using SolidWorks since 1997. I've got a lot of experience in SolidWorks. I think it's it's come a long ways in the last 10 years, so I'm excited about it, but it's not Creo, and people just complain about stuff that they don't understand, and I just tell people, quit being emotional. Let me just show you how this tool works. So I'm scrolling down here to the Creo training. This is the big piston here is where Creo starts. This is our 1 week learn to design course. People with 5 years on Creo should take that course, and you definitely won't get bored. People with significant amount of SolidWorks or NX, they should take this course as well. I'm scrolling down, top-down design, pro program. I know a number of you on Zoom have had classes at Design Engine before, probably less than 10%. But here's our surfacing week 1. Each one of these links is a 2-day class. So there's 4 2-day classes kind of crammed into a 5-day week 1. Week 2 starts with advanced surfacing. My definition of advanced surfacing is very different than what PTC might call it, advanced surfacing, by the way. And aircraft surfacing, I'm coming down here to the REX and the import data doctor. So this is leading me into my talk today. So I put together a series of 2-day classes that make up what we call the reverse engineering week. So reverse engineering means many different things to many different people. If you're talking to a double E, they're thinking reverse engineering, how a motherboard works, or maybe reverse engineering software. Of course, we look at a competitor product and think about how that might work with the CFD or some structural integrity. So what often happens is the manager says, go out and get a scan of that thing. And as a good young engineer would just do exactly what they're told. What we need to learn how to do is ask kind of narrowing questions without sounding like we're being argumentative, right? Because it can be really it's easy to sound argumentative. Well, why do you want the scan? Well, I don't know, just do it. Well, what I'm trying to get at is, if we do this scan on this manifold and you want to do a CFD on it, and the manifold was designed in 1950, you want a baseline so we can change the design slightly, run a new CFD, iterative, right? And so the manager often gets frustrated when they get a scan and they can't change it at all. So my 1 week reverse engineering class shows you how to use the scan software that basically take the faceted data and wrap surfaces around it. Most people are happy with that. Sometimes you need import data doctor to make that a clean surface to come in stitched properly. Thirdly, you want to make it parametric so you can change it 20 times and run 20 different CFDs to optimize the shape. That's what behavioral modeling is doing. Maybe that's a talk in the future. And we can use all kinds of tools inside, like this flexible modeling extension. It's I'm not sure how to describe it other than I've been teaching import geometry for 30 years, and flexible modeling is pretty badass stuff. I don't know how else to say it other than, if it blows me away, it should definitely make you quiet for a minute. Blows me away. All right, so I'm just gonna quit rambling and jump into the data doctor exercises, and I'm just gonna scroll down to show you. I've got a bunch of little exercises to do. I think it's important to start from the beginning. If you were to give me a 2-day class, you're by far the expert at managing imports. But what we do inside that import is we convert everything to be parametric. Now, I remember it was a Michigan Creo user conference that I was at, And there were two gentlemen, I overheard them talking like, everybody knows you can't make dumb step data parametric. Let's go see what this idiot's got to say. And I was standing right there, you know. Well, I teach that class. I can make anything parametric. It's a workflow. So maybe that I've done that talk at the Badgerland user conference probably 15 years ago. But it's really simple. Everything's a workflow, right? So I'm just kind of scrolling through this thing. There's a bunch of assemblies to play with. Here's some imports that didn't come in, so we got to rebuild it so we can make the solidification occurrence happen. And maybe it's not shelled out. So here's a Merkava tank, pretty cool stuff. So I've got a whole bunch of exercises to play with. This is a sheet metal part, and it's very difficult for me to choose which one to do. So Deb had mentioned, hey, there's a couple people inquiring about nuts and bolts. So I was just going to kind of start with a few things and play around. So this bicycle is from we've machined it and we're racing it this year. This is a SRAM sponsored race team racing in Denver. Look, it's got a high pivot. So the design director of SRAM sent me a bunch of files that they had, and they delete stuff off the import so that we can't go and reverse engineer it. So it was a couple years ago when I was designing these parts. So I probably spent 20 hours just solidifying all the geometry. The front forks had holes all through it so that someone couldn't build a solid geometry and machine them, right? I fixed everything as an exercise. So it's an extremely valuable skill set to have. Taking something that shouldn't be 3D printed or, you know, machined and setting it up so you can machine it, right? You give me the model, I'll make it. I'll make it on my CNC machine, right? So I just thought all the components that SRAM gives us, including the chain, is exported out of Creo and ultimately created as a step file. So what I'm going to do is I'm just going to do the very first exercise of our surfacing class. This is a really good introduction to what are surfaces and what are imports. So what I'm doing is I'm modeling just a simple little L bracket. I don't care about how it's dimensioned. I'm just going to extrude it, hit the middle button. And I'm just going to export this as a IGES file. IGES is just quite a bit older than a step. And then I'm going to bring it in incorrectly. Some of you, I recognize your names. You've had a class with me recently. And the joke is, if you wanted to complain about Bart's class, you say, well, the instructor showed us how to do it wrong. Well, that's exactly why I show you how to do it wrong, so you don't do it wrong at work, you know. But if we try it a few times, we get pretty good at it. So I'm going to say IGES file. I'm in my Creo 9 import folder. I go file open. File open. I'm going to open the IGES file. So this is one of the things that I've been pushing PTC to do for a number of years. I'm going to say 20 years. You see this button? It says use templates. You can set this as a config setting, but nobody does. And I can tell you it wastes probably 4,500 hours a year with most organizations, including the US Army. 4,500 hours a year is a huge number. If they just made this default, it would be so much cooler, right? I'm going to leave it off and do it wrong on purpose. Where's my datum planes in my model tree? Every single model I get from India and China come back like this. All right. Well, what I do is I write a script on 500 parts that I got to make drawings out of. Our team's doing work for toy companies around the world. Then you build the 3 datum planes, resume them. Then you got to rename all 3. I want my script to do all that for me. It works about 80% of the time, you know. And then you got to add all the parameters from wind chill. So if you're ever involved in hiring an outside company and the outside company doesn't ask you for your start part, big red flag, pick a different consulting group, right? So that's not how I want to roll. So I'm going to go file open, go for my import, and pick use templates. Now it's grabbing my start part. Look, datum planes. I got all my named views. All right, so I start out this talk on this point because it just angers me how many hours we waste fixing stuff that would have been very simple if people would have just had a class. Sigh. All right, so I'm going to edit definition on this import. Hey, it came in solid. I don't need to edit definition on it because maybe I'm Kenworth Trucks and I buy a lot of parts off of McMaster and I assemble that after sourcing it on my tractor trailer, right? So I'm going to go to this button here. Now, if I were involved in the PCC user interface, I'd make this thing way bigger to make it more prevalent. For some reason, they got it kind of small, but this is the import data doctor. And by the way, I was told by PTC 20 something years ago, Creo 4, Wildfire 4 import data doctor was new. And I was told it was my idea. I may have mentioned it late night at a restaurant or something. I don't know. But so what I've got are a bunch of surfaces that I can shift select and delete if you wanted to. I'm going to hit Control Z because I have no intention of deleting them. So you can pick them on the face and get rid of them. Okay. I'm going to close out of here now. Import data doctor, right? I'm going to close out of here and I'm going to close out of here and I'm going to open up that block that I just had a moment ago. I don't remember what I called it. And I've got a bunch of stuff in memory. So I have to remodel that square. I'm going to re-export it with another little setting. So as we learn surfaces are really nothing more than an interesting hammer to use for an engineer. It's a tool that can be utilized to make you more effective. Okay, so now I'm going to file save as copy, and I'm going to save out as an IGES file again. Why? Because IGES files tend to be a little old. I'll just overwrite that one and call it 3. This time I'm going to go into my options and change a few things. Instead of exporting it as surfaces, I'm going to take this bottom option. Oops, I meant to hit OK, but my Zoom interface is in the way. There we go. Now I'll just leave that open, and I'm going to go File, Open, and I'm going to grab that IGES file again. Okay. This time it picks use templates. By the way, there's a config setting to set that. Okay. Now I've got my default datum planes, and look, I've got these extra curves on here. So let's go and edit definition and investigate what we get here. I'm going to click on my import data doctor. Hey, look, in my model tree, I have a couple extra things to kind of mess around with. I'm deleting some of these surfaces here. You could window the surfaces too. You got to come down in here and segregate down to surfaces. If you left click here, anything you circumnavigate gets picked, top left, bottom right. This is Microsoft industry standard for 25 years. Bottom left, top right, anything you cross gets added to the selection set. So I'm just deleting all the surfaces, and look, I'm left with the wireframe outer geometry curves. How is this relevant? Well, if I have to go back and rebuild this stuff, I have things I can go back to rebuild with. This is kind of going down the road of how I make it parametric. So look, now I can go in here and I'm segregated to surfaces. I'll go back to all the geometry, and I'm just going to pick all the vertical lines out here. Is anybody trying this as I go? I saw Matt join. He used to teach this class a while back, Matt Holter. I'm just kind of removing some of the vertical geometries here. And now this is where in the surfacing class, it can get a little bit confusing if you're not paying absolute attention. Usually in the surfacing class, this is a road less traveled, building it all inside of the Data Doctor tool. Look, I've got everything I need to rebuild this geometry. Now it's a class. I deleted stuff. It was kind of perfect before I deleted it, but you get it. I'm going to check out of it and get back into Creo now. I'm no longer in the Data Doctor. And I'm going to build my curve tool to reconstruct this stuff. I might change my user interface a little bit. Your curve tool is going to be sitting in here. All right, so since this is a Data Doctor class, I'm just going to go in here and rebuild it inside of Data Doctor. So this is where it's going to be a little confusing for you if you come back and look at this later. This tool allows me to build it inside of Data Doctor. I don't work at PTC, but I imagine their India partner built this tool. Who knows? But it works quite a bit like the style tool. In this case, I have to hold the control key down to pick the other side. And how do you know? Well, if you don't hold the control key down, it becomes clear that you need to hold the control key down. So I'm using my Creo intuition, if you will. So here I can go back and reconstruct this whole thing real quickly inside of the tool, and I can do it outside of the tool. Kind of whichever you care about. Now, the typical BSME is going to think, hey, it's got to be better outside of the tool because I maintain some parametric ability. But you're tying it to something that's we call it dumb data. It's not modifiable, right? I can modify it. It's quite modifiable, but most people think of it as non-modifiable data. Right? And now I can build up surfaces outside of style. Or I can build surfaces inside of import Data Doctor. Right? So the difference is the surfaces built up inside of Data Doctor don't maintain any parent-child constraints, much like Rhino. Rhino is that. I don't know if anybody ever messes around with Rhino, but kind of a toy. We teach Rhino. We're actually teaching a grasshopper class this week. I should be down there taking the class. All right, so now I've kind of mixed and matched. I got a couple curves built inside of style and a couple outside of style. So what I'm going to do is I'm going to shift select the entire model tree and come over here to editing and collapse everything inside of the tool. There's some really interesting workflow ideas for managing modifications to a model. Maybe I can get that before the end. But look, I collapsed everything back in there. There's some stuff like that seems kind of not like a big deal, but that's pretty impressive to be able to do that. And there's a whole slew of workflow that we can think about. Now, what I'm getting to here is that we can rebuild problematic geometry if necessary. Hi, Rowan. How you doing? You want to say hello to my friends? Say hello.
Hello. Daddy, are we going to the pool?
We're going to go to the pool later. Yes.
With class.
Right, so I'm building all this stuff up inside of the Data Doctor. You know, you have a choice. I think that's pretty cool. That's the best part about being American. You got a bunch of choices, right? Now, how do you merge all that together? Well, let's check out of it and see if it auto merges. Hey, it's not solidified. See? So merge, if you know surfacing, is a technique that here combine. Okay, so now I've combined everything. Let's right click on it and see if it'll let me solidify it. Yep. Let's delete the solidify, redefine the import, and see if we can add add bodies to the mix. Okay, for some reason it didn't work, but that's okay. We can just solidify the whole thing. Now I'm back to what I had originally. I can shift select both of those and collapse that, and now I'm back to what I started with. So any questions? That's my first little example. I was just going to go down to the second example and play around with this pan head screw, if you guys are good with that. All right, I've already exported this button screw, whatever we're calling it. Okay, and I think, I don't remember who it was, but somebody mentioned, how do I delete the threads off of something? Well, there's a bunch of ways to do it. The simple, easy way to do it is just to create like a big old extrude, right? And some of our managers get kind of emotional about having too much extra geometry in the model, because it can slow down the spin and shading of the model. Look, now there's less surfaces in the model. That's the quick and dirty. The part that blows me away is what PTC has done to flexible modeling. Now I'm involved in a lot of the development of how Creo gets built and stuff. I encourage you to be on the technical committee. I'm going to click on the import data doctor, and what I'm going to do is I'm going to delete the Allen head hole here. So if you're good at building selection sets, you're probably an expert at Creo. I'm just going to click on anything here and use the shift key. Look how it automatically collected all the, dude, I wish SolidWorks did stuff like that. Kills me. You got to pick every single surface. I don't know how they get away with it. It just, like, SolidWorks people just like clicking on shit, I guess. So let's hit close here. So what I did is I just deleted a hole. That absolutely blows my mind. I'm going to undo it and do it again. So this is how oftentimes early adopters like me will get in here and just play with every tool inside the import data doctor and learn things that I didn't know you could do. This is how PTC would roll out. I don't work at PTC, so I should be careful how what I don't know, right? But this flexible modeling extension, this is where they exposed all those tools to let dorks like us play with it. Flexible modeling is wicked. So I'll do it again. I'm going to click anywhere inside. I'm going to hold my shift key outside and shift select everything in between. Close. All right. For the flexible modeling, they use a different term, remove. Let's see if we can remove the ribs, the threads. So here I got to hit control. I'm looking here, let's remove the chamfer as well. All right, it looks like I got the thread selected, both I'm holding the control key now. I got the left and the right side of the thread. What do you figure is going to happen when I hit close? Look, I left something off here, right? I got everything. Let's hit close. Hit the middle button. The spinning ball of death for a second. I would expect it to have been done by now. Okay, maybe I had too much selected, right? So we'll try it again. Pick the inside, pick the outside. This time, I'll just grab the chamfer as well. Hit close. Next time I'll try and I won't grab the chamfer, or maybe I'll just grab the chamfer. While it's thinking, I'll look at the chat window. Some people making jokes on here. Maybe I should have grabbed the inside wall as well, right? So you can hit this little stop sign down here if you want to stop it and try something new. I noticed on a wish list, somebody said they wanted a stop sign. I was like, well, I thought they already had one. So this time I'm going to build my selection set a little differently. So this is all about how you learn, right? You got to figure out how you're going to build stuff. I still got my spinning ball of death. Okay. Got back out of that. Okay, let's try it again. This time I'm going to grab the inside wall and the ribs and the chamfer. Let's see what we get that time. You know, and if you really want, you could just delete the or just create a solid over it like we did initially.
Bart, this is Deb. My employer, so, you know, I don't know if you were in right early, does not want these threads, and you've got 100,000 plus component assembly. They also do not want us to like just extrude over them with a surface or, you know, extrusion and solid extrusion. Because they said that, okay, that it's still in there, you know, maybe visually, but it's still in there, still complicates the model. So anyways,
I disagree, but there's two types. I don't mean to be argumentative, right? Because anytime you disagree, it just sounds argumentative, right? There's two ways. If you used Creo before, or Pro Engineer back in 1990, you had Creo 7 or Pro Engineer version 7 and 8 had two ways to save. One was the long way, one was the short way. Does anybody remember that? The long way saved all the features. The short way, you would go, basically it went into insert mode to feature 4 before any protrusions occurred. And when you opened it, it had to regenerate the part. One was very tiny and one was very big. So we don't do that anymore. I think around version 9 they quit that, maybe version 10. So if you cover up the geometry with a protrusion, it seems kind of pointless, right? It took a little extra work, but what happens is there's less there's less surface data to spin and shade. There's less facets to shade. There's less triangulation that has to shade the NURBS surface. It becomes a polygon when they shade it, right? To regenerate the model, it takes longer because there's an extra feature, but that technique, that whole thing has gone away. It's still there, but it's quite a bit more minuscule. The shading of the facets on the NURBS geometry is where the large assembly causes the slowdown of the large assembly. We call it large assembly mitigation. But anyway, the threads are gone. Does anybody want to see that again? I can hit Control Z and get back to what I started with. I have 20 minutes left. Let's see. Let's look at what a trim surface is. So I have quite a bit of experience using Alias software, which is what the automobile industry uses. Tesla uses Alias to make the outer geometry of the cars. I think Creo can get real close to what Alias can do, but it's really hard to beat Alias, right? So what I want to do is just show you what a trim surface is. This geometry started out as a square, right? And in Alias, I built a curve across here and projected it onto the surface and then trimmed it. So in order to be good at fixing import geometry, you need to know what a trim surface is, and Creo doesn't really have any vocabulary for that. Sort of, right? So what I'm going to do is I'm just going to click on this geometry and literally hit delete. It just got untrimmed. But if I need to recreate that trim, because I need to be parametric or something, how do I know where it was? It's too late. I already deleted it. All right, so I'm going to check out of here, and I'm just going to build a composite curve off the top. Control C, Control V, have the curve on top. I'm going to collapse it. Remember the collapse utility right here, middle click. Now I'm going to edit definition on here. Go back into my data doctor. I'm going to click on the edge of the surface and hit delete. But look, now I have a record, a fossil record, if you will, of where the curve needed to be before I built the trim. Collapse. This collapse absolutely blows my mind. I've got a whole bunch of tips and tricks to play with in that week 2 surfacing. I'd be curious to get a call of hands to see how many people have had week 1 surfacing. That really sets people up to be in a very different category. Week 2 is just expert status. Comments, thoughts? Unmute yourself and speak up. I'm not able to catch all the comments coming through chat.
Hey Mark, this is Tim Walker. Long time no see. But yeah, I was thinking back to the previous
Tim
example.
Doctor, I recognize your voice.
Heck yeah. Thinking back to the previous example you gave, I think that was kind of perfect for what Deborah was asking for. You know, she's saying the boss doesn't want to be doing the extrudes over the threads or anything like that. We want to simplify this geometry, and that deleting the threads with the import data doctor tool, I can't remember the name of it. Close? Was it just called close?
Close and remove. Yeah. They
I mean, the total number of faces, inside that import geometry feature is reduced by it.
Yeah, that was great. I actually have never even tried that close, so I'm going to do that thanks part. That was great.
Yeah, that I don't want to act too excited about PTC, but there's some smart dudes working there. I'm impressed. So I built this in SolidWorks and it exported it into Creo. So I recognize what's going on with these green surfaces, that we call those in our top-down design classes delineation geometries, because they delineate between all the components in the exhaust. So in our naming convention, 00 is the top-down design leader for that. I'm just going to delete that. Now I've got the first through 6 components in my geometry, and so far it looks pretty good. You know, I could probably make drawings out of all this. Let's just grab one of the parts randomly and look at it. Hey, it's a solid. I almost don't care, right? Just as long as it's solid. How do you know if it's solid? Well, in my case, I exported the curves, so it could be a little trickery. I go to wireframe, and if I see any pink, then I know that's a surface that has not been merged. So what I'm going to do is I'm going to take it back to the import data doctor, and I'm going to delete all the curves, or maybe you would consider adding them to a layer. I'm just going to delete them for sake of time, and check out of it, and check out of it. And you know, I think that's a solid. A second methodology, you'd cut cross section through it. If you can see the cross section is a solid, then it's probably a solid. And if you can create an STL file out of it, it's probably a solid. So you define solid in your own way, right? So that guy looks pretty good. Let's go look at the next one. I don't know if there's anybody from Harley on here, but Harley, they got to be really careful. Anything that gets chrome cannot get modified. You know, if they build it in Alias or any of their other outside of Creo tools, and I bring it into Creo and I pull my import data doctor on stuff, I got to freeze certain things because there's a tool that helped me build something. I recognize that as not part of the model. Here, I'm going to delete all the curves just out of the model tree. Let's take the shade mode off and look at it. Hey, there's some pink stuff. That means it's not solid, right? So I got to check out of here and guarantee, you know, hey, is it truly not solid? And like everything in Creo, there's no right and wrong way. I don't know. I like to say the wrong way to do something is you discovered through trial and error that that's not the right way to do it. You really have to push yourself and play with these things. So what I'm going to do is just kind of look to see what didn't get stitched and think about it. Well, what you could do is you could actually delete the surface, re-import it with another one, and see if it merges. What would that tell you? That maybe there's a little tolerance issue, maybe. This button here is reminiscent of pre-Wildfire 4. People often complain, why do they make it so complicated? Well, you know, I don't think of it as more complicated. This is zip gaps. You just repair it and you don't care, right? But when you look in here, the surfaces got convoluted and it didn't quite repair right. So I'm going to hit Control Z. I like problems to chew on, right? So
Howdy, Bart.
Go ahead. Whose voice is that?
Hey, it's Matt Holter, California.
How you doing, Matt?
Good to see you. Are you hip to the activate portion of the import data doctor?
Well, that's what I was getting ready.
Oh, you're getting to it? Perfect.
Yeah, I was going to activate these geometries. Go ahead. What were you going to say?
Oh, that's all I wanted to share with the class here.
So activate, and now when I hit repair, it just works on just those surfaces. Yep, thank you, Matt. Now I'm going to try to hit repair. Right, let's take the shade mode off and see what we get now. There's still some problems. This one, this one, this one, and this one. I think I remember hearing somebody say there's not a lot of documentation for this stuff. It looks like now I've got a problemos on the outside. So what activate does is it kind of works like how we did it old school. I would bring in these geometries as separate geometries and merge them. There's two types of merges. There's a join merge and an intersect merge. Can anybody articulate the difference between those? I think of it as join is when the two surfaces are butt up perfectly together.
Yeah, they're kissing
Intersect
off
is when they're not. Intersect happens to be more accurate. Join tends to be a little less accurate. I don't work at PTC, but that's my backstory. All right, I'm gonna deactivate everything and then check out of it. And hey, it's solid. That's working some real magic there, getting that thing to resolve. Now I can just make a drawing of it, send it to the printer, whatever you're gonna do.
Hey, Bart.
Yes, sir.
Hey, this is Joseph Wig. I threw this in the chat. I'm not sure if you were going to talk about it. A lot of times what we do here is we use the search tool on the bottom to search for single-sided edges.
I haven't gotten to that part yet.
Okay. And then
Yeah.
the other thing that I wanted to say was, were you planning on talking about the geometry checks and the import data doctor as well to help?
Probably not.
Okay,
Yeah. So what, James, you said your name?
Joseph.
Joe, what he's talking about is you can search for gaps. I find Control F to be really funny when I'm teaching a class. I got to like Control C, Control V, Control H, Control Y, Control F. Most of us, the programmers that work at Design Engine have referred to F and H as search and destroy, because usually you're doing it on a big database and you can change things in the database. Control F will search for gaps and let you here, this one, I'll delete the curves out of here just to show Control F action. Just delete the curves that way. So taking it off onto wireframe, you're hyper focused on the pink. A lot of people that take training are running with 25-year-old colors, and well, Bert, I can't see. What happens is their system administrator was an expert 20 years ago, and they like the old colors and they push those out. I think that's a mistake. PTC does a lot of user usability studies, and they found an optimum color, right? But we tend to get used to the old colors, and that's not cool. So what I'm going to do is I'm going to hit Control F here and try to find any of the gaps. I did a Control F, but I didn't narrow my search. So I'm going to hit Control F, and I'm going to bring this over. I'm just going to type in G for gaps and do find now. Maybe this isn't the best example to find the gaps, but you can make it bigger or smaller and ultimately narrow down your search.
So what we do is we search for, if you search for edges, there's an option to search for single-sided edges. And that's how we find which edges have issues.
Mm-hmm. And if you found the edge, you can just pick it. You pick one side of one edge, one side of the other edge, and this just isn't that example, forgive me. I thought maybe it would fetch that. These edges happen to be right on the money, and it's the same problem as the other example. It's going to convolute the surface. So in this case, we would use the activate to allow just those to be repaired. And you kind of work your puzzle like that. Let me see if I can find another example. By the way, this import came in as an assembly. I meant to discuss that. If you're switching from SolidWorks to Creo or Creo to SolidWorks, you've got a whole bunch of legacy data that you need to be able to work with. You can mitigate that data by building the assembly just like it was exported from SolidWorks. Let's see if I can find another example to play with the search stuff. Okay, so I built this in Creo, brought it into Alias and tweaked on some stuff to make it kind of ugly. Something to chew on in class. And I'll just go to import data doctor, turn off my shade mode to get my head wrapped around what might be a part of the problem. and I have this surface here. If you'll let me burn through my 10 minutes here, I'm just going to delete the surface completely and reconstruct it in a very different kind of way. This is a 1-hour crash course, but in the 2-day version of this class, we go through and build all these things several different ways. So what I did is I just built a surface out of the whole thing using the fact that this and this was flat. And now I'm going to trim inside of the geometry. Let's see. I'll pick the surface and hit trim, and I'll organize my trim selection set using my shift key across here. All right, now I got to merge that whole thing back in. And how you merge inside of Data Doctor is you just drag it inside of the body. That merged it. Kind of a trip, huh? When I check or when you turn the shade mode off, you can see there's no purple around that edge, you know. There's all kinds of ways to work this sort of magic. Let's do a Control F here and search for gaps and see what we get. This one doesn't have any gaps in it. Maybe PTC has one that's kind of gapped perfectly. I'll drag that one in there. This is a PTC example from a PDF that was from some years back. Let's get in there and go Control F here. Fine now. Oh, I have to activate the whole thing probably. All right, let's fix it first. So I can take that surface. There's a bunch of different ways to mitigate this as an issue. Move vertex. I kind of feel like I'd like to have an O snap. If you know AutoCAD, O snap would let me kind of pop it right on the money. You know, I'd like a setting for O snap here. This model is a little too awkward in how perfect they made it, you know, perfectly messed up so that we could have something to play with. I'll unactivate it. Let's see what I can do with my Control F. I'm not sure why I'm not getting any gaps here. Usually this would show up as I'm going bigger or smaller just to see what my problem is here. If for some reason it's not giving me a gap, but I know that there's a gap here. So I was going to try to pick one side, then the other side, hit the middle button. Then I can hit repair. And that would collapse that gap. You know, that's the zip gaps that one might remember from 20, Creo, Wildfire 3. I'm not sure why I wasn't able to use Control F to do that, but that's usually how what I do is I'll search for gaps using Control F. I've never really used what I'm getting ready to do here. In a production model, this is kind of a replace. Let's try that again. Probably because I've already made some changes to the model, it's not going to let me do it. So I'm going to do that one first now. Pick this edge and hit replace with that geometry, middle click. That's I think Creo 9 it doesn't let you do that one. I believe
That one's kind of finicky, Bart. from what I
Yeah, I've
remember.
never really had too much luck with replacing. a
Yeah.
production model.
I've had when I've had to make models for the FEA guys that are all sealed up and don't have any gaps. I use that one outside of the data doctor.
Yeah.
That offset replace command.
Since this is supposed to be flat, I'll just reconstruct this one like this. And since this is now flat, you can actually sketch upon it. That'll blow some people away. And I'm inside a data doctor playing in sketcher mode. Hey, you know what? It's not tangent at the bottom. You could probably get it to go tangent. It's a little struggle bus. But it, for some reason, doesn't let you do both. But we'll just leave it at that. I mean, there's 100 different ways to skin these. Usually people don't care. They just want it skinned. But, you know, the Harley guys, they're bringing in an import and they don't want anything to change that's chromed. So we freeze those. I didn't demo that. Okay, and now I'm going to trim. Here, now I got to use my shift key to add to it selection set across there. I'm fetching the geometry that's underneath there. Right. And if I want to drag that into this mix, it's now merged. That's kind of the trip. Consider turning your shade mode off to see what you get. And there's no parent-child constraints, so you can actually just delete any curves you built. It doesn't delete the surface that the curve you built. This boundary blend, you can build that just like you do any other boundary blend.
Bart, we probably should wrap it up. Does anybody have a quick question, or do you want to just probably another minute or two?
Yep. Well, I hope you were able to learn something.
Art, can you hear me?
I can. Jeff Ingham.
Yeah, how's it going? So that PTC model there is way too simple. Like I just pulled up a model I've got here for that's an import from.
I've been asking for people to send me models for 2
I can send you
weeks.
tons of them. This particular one, if I do a quick geometry check and import data doctor, it pulls up 9 bad surfaces, 26 bad two-sided edges, 147 bad vertices, 15 unsatisfied wireframes.
You know what's funny, Jeff?
Not added to wireframe.
What's funny, Jeff, as I was at a major manufacturer, not Polaris, but I was at a major manufacturer, and an engineer was complaining exactly like you are. And I sat at their computer, they took a phone call. While they were on the phone, I fixed it, solidified it, and they said, "What did you do?" I was like, "Nope, got to take the class." Send me your model, Jeff. I'll fix it.
Sure, we can talk offline.
Yeah, and if we want to, follow up and do another session on this, maybe in July, if Bart's available, or if you guys just get back to me, and if this is, I got a lot out of this, but it's me, and it seems like other people are enjoying it too. So just
originally, I was going to do the Rex software, take some STL files and kind of play with that stuff. I could take the inner ear of a scan of an inner ear and create that into a cavity where you could pour wax and have the perfect ear canal. Rex software. I'm teaching that class in July. The reverse engineering week. I won't mention the company name, but lots of good stuff. So this is the scan of an inner ear with a infrared scan. I think maybe it's not infrared, but then here I built a perfect stitched model and reversed the merges to make a wax cavity to pour the silicone into. But that's a 2-day class that we do. Usually people have something very specific that they want to do. So, hey, if you enjoyed it, send me an email. I really appreciate hearing from folks. we're excited to meet people and of course to do training. Consider sending some of your young people for classes at Design Engine. We'll try to send them back showing you something new. Bye, everybody.
Thanks so much, Bart. It was great. Hopefully
Dave.
the recording will work and then I'll post it. So I'll let you know. Thank you.
Cool beans.
Thank you. Thank
I
you.
didn't see everybody's chats and stuff, so forgive me.
Thanks, Bart.
Yep.